I came from Bratislava here to speak on the Scylla Summit and share our journey to migrate from Cassandra to Scylla. And on this summit, we encountered many similar use cases that ours, and it's great to share the similar experience that we are having still on the journey. Perfect. Hello, everybody. My name is Martin. Thanks for the introduction, so I don't need to do it myself. And let's jump to next slide, right? So Kiwicom. Guys, honestly, I explained like 4 times already, no, we are not from New Zealand. We have nothing to do with the little bird and nor not the fruit itself, right? So who we actually are. So we are we are a travel company. What we do, we have developed a platform that actually combines flights that usually you can't find. So imagine you have one alliance and second alliance. So usually when you have multi-leg flights, you don't get the combination between them, right? So that means like you don't have all the possibilities, and you can't find all the possibilities how to get from point A to point B. What we do, we combine them. So actually, you can go through one alliance. Let's say it's a Star Alliance, and then on other side, you can have any low-cost carrier added to that, and we will get you from point A to point B. As you can see on the picture, so I wanted to travel from Bratislava, from Slovakia, to San Francisco, through London. And you see, we find you several flights. And on the bottom of the picture, you see the ranges for the prices and the length of the flight that it's going to actually take to get there. So what is our problem? The company itself grew significantly over the past couple of years. So it started as a crew of two guys that wanted to travel on a budget. And the problem was that all these searches that they wanted to go from A to B, they had to do manually, because they were combining either low-cost carriers or legacy carriers together. And there was not a platform that can combine it through one to another. So they started to develop a platform, and they started to do storage in MySQL as a first. Then moved to Postgres, and the company at that point started growing significantly. So the easiest solution was to let's multiply it and let's have many Postgres databases and get the data out of that. In 2016/2017, there was a decision, let's go to Cassandra, because it seems like a good idea. Right now, we are in 2018, and we are at the migration to ScyllaDB. So what numbers we are facing? We are facing like 7 billion of flights at the entry side. So that means that we are getting those data, and we are combining them and creating those custom routes for you, so you can travel on a budget somewhere. In fact, for the technology, it means we have 350K of writes per second all the time. We have 600K of reads per second for that cluster. And now we are kind of starting to stretch it, right? Because you don't have the consistency on one side and on the other, and the ratio can change significantly over time. The size of the data set is not that big in volume. We have like 20 terabytes in multiple replicas. And that's not significant, but when you combine it with the triple V of data, then you see that it becomes a challenge. In the flight industry, since flights are always being purchased, always there's like, you know the problem, I start looking at the page, and 5 minutes later the price goes up, and then the price goes up, and then the price goes up, right? So that's happening also because like everybody purchases a flight all the time. So in our database, we exchange 60% of the data every single day. In a week, or well, in 10 days,
we exchange everything that was there. So that means like the constant change. So there is not something that, we don't need that and this can be updated later or something. We don't know, actually. It depends on you, what you buy, and when you buy it. So let's go back. In 2016, the Scylla was released, right? There was the first GA version, and basically we were thinking like, is ScyllaDB ready for Kiwicom? So this is an email from our CTO, Joseph, that brought to door and asking like, hey guys, can you help us? What you can do for us, etc. And a couple of emails later that I went through them, they figured out that no, because Scylla didn't have lightweight transaction, still doesn't, and secondary indexes. Yay, they are here, right? But honestly, like when I was preparing the slides, I was talking to our team and asking them, like, guys, why we needed that in 2016, and nobody knows. So, as you can see, it was 2016, right? And let's see that November 9th, 2017. So it took us nearly a year to get on Cassandra running and full traffic there. So why it took that long? The problem was that the company, since it was growing so fast, always new challenges came up. The problem of Cassandra was that it was not able to sustain the amount of reads that we needed from it. Yeah, you can throw a value store in front of that or Redis or whatever you can do. The idea was, let's read directly from the SS tables. So actually there was a bypass for reading some of the data directly from SS tables because we couldn't get them through Cassandra itself. Sorry for that. So why we are talking about ScyllaDB? So we didn't end up yet in like, the company is like, we want to grow more, right? Right now we have more than 2,000 people, and on engineering side we have around 350 people, right? And that's pretty great numbers if we're speaking that the company started in 2013. So where are we heading? The ScyllaDB migration is not only about like lift and shift from Cassandra to Scylla. For us, it means we need to do some serious changes to our infrastructure. And as you can see in this picture, so we have AWS, right? And we have our API endpoints there. And the second provider that we have all bare metal there is Hetzner. The problem of this provider is that the data centers are in close proximity. So basically, that's why we have right now 4 replicas of Cassandra. And also because it's not sustaining all those reads, right? But that's another problem. And this is like, for us and future growth, a significant problem. Because everybody knows this, right? It's a lovely icon. Yeah, but if you are at one location, everybody knows that where there is a big thunderstorm that is becoming so usual everywhere. That we would be just sitting ducks, and yes, this is fine, and nothing will be working if there is a power outage, for example, within the data center. And we don't want that. So we need to do some changes. So what are the changes? The biggest change that we have, we want to go global. That means we want to have at least the data center, the replicas distributed within several data centers. In different locations, cities, continents we are not speaking yet, and Elon is not yet on Mars, so let's not put it there, right? If we are speaking in terms of cloud, it could be multi-regional distribution or multi-AZ at least. And yeah, we want to get rid of the custom stuff. The custom stuff is, for example, the SS tables reads. Why so? Well, you would have to rewrite it all the time whenever you're doing an upgrade and there is a change. Going to Cassandra 3 would be the same thing again. You need to rewrite it, etc., etc. So this is what we wanted. Not only the change on the Scylla side, but also the GCP side, right? AWS to GCP. And we wanted to have like multi-zone deployment of the Scylla, and mirroring that on the API side of our endpoints. And we headed to the POC. So we met Greg, and I think Dor was there, and Glauber on the call for the POC, and starting discussing like what we're gonna do, what are the minimal criteria for accepting it after the POC, etc. And that was around March this year. What we wanted to test. So first, how fast ScyllaDB can go. You know, when you read a benchmark, a blog post or something like that, and you blindly trust it, that's your fault, but we are not from there. So how it can handle our standard usage. So that means all those reads and all those writes. And as also Glauber mentioned today, all our full table scans that we are doing to that. Should we go bare metal or should we go cloud? And basically, what's going to be the cost of it? Because we knew at that point like how much cost us to run the Cassandra cluster. And we didn't want to get into any configuration issues because like the configuration of Cassandra, some would say it's pretty easy, some say it's hard. So how we tested it? So we at first wanted to see the same comparison of the same test on Cassandra and ScyllaDB. So we got 5 servers, and we compared the same traffic, the synthetic benchmarks of well-configured Cassandra and well-configured ScyllaDB, thanks to ScyllaDB guys that were helping us on that. And we just threw the Cassandra benchmark basically on it, and we compared like the numbers. Okay, like. Yeah, it can be optimized for that, and it looks pretty awesome, right? Another part of the test was testing GCP versus OVH, that's another bare metal provider. And we wanted to see like what is gonna be the result for the GCP and what's gonna be the results for the OVH benchmarking. And on top of that, we have been testing a lot of GCP to GCP to GCP to GCP to GCP configurations, and we were trying to find out the best one. Spoiler alert, we didn't. So how we tested? Oh, I already said that. Synthetic benchmarks, yes, that was the first one. Shadowing production traffic. So to each of the configuration, we set up a shadow traffic to that cluster for the writes. Because we wanted to see like, okay, how it's gonna behave on the custom traffic that it's really impossible for us to simulate. Because we don't know what is going to happen like on market, on Earth itself. Like when there is going to be a problem and another eruption of a volcano, for example, the flight is going to be completely different, and you have to book different flights, etc., etc. A lot of people will be searching for different routes, etc., right? So we need to shadow the live traffic. Otherwise, the test doesn't mean anything for us. And we had to develop internal tool for the benchmarking of the reads. So that's basically you searching, going home from ScyllaDB conference or heading here, right? So this is like something that is, again, unpredictable. But we figured out, like we got some part of that searches. We figured out, okay, this seems okay. Let's throw it, and we were replaying it on this side of on the reads. So what we ended up, we had a good comparison and understanding where we're heading. So the Cassandra that we had, the cluster, still have, it was around 100 nodes. And let's say, yes, this is the replication factor of 4, as I described. The ScyllaDB that we estimated would be around 21 nodes. The 40K reads and 900K reads, guys, this is actually from the benchmark of the 10 nodes cluster. So this is not like the full cluster, but this would mean like we test, this is only the result. So if you see the magnitude of comparison for the reads between the Cassandra and Scylla, you know the winner, right? We hit the jackpot on that. What next? The GCP to GCP. So it's impossible to read that, but don't mind, right? So there's like a lot of configurations on the GCP storage. So we tested NVMe drives, we tested SASI drives, we tested SSD drives, we tested their network persistent storage, We tested different CPUs. We did all those benchmarking. We can share it for marketing purposes to Scylla, but our copyright needs to be there, right? The point was that, as I said already, we hit a spot where we said, like, this is no go. So why it happened? Like, we collaborated with Google, with Scylla team, and our guys on finding a solution for several months. It was not like a week or something. We were trying to do it really hard, but we found out that there are some issues that we can't really cope with, and we don't want to go that route. So on the GCP testing, one of the issues that we hit, but was really easy to overcome, was the CPU variation between regions and zones. So if you want to do regional distributed system, then you have to look up what CPU families they provide to you within different zones. It is not one-to-one. That would mean like your configuration of the ScyllaDB cluster would be like completely different, and Glauber would go bananas because he can't support it, right? So he was like, whoa, how can we configure it? How can we standardize it? So there was no go for that. But it was easy to fix it on the GCP side. There was no problem for that. Another part that we hit really bad was on the operating system. They developed a shadow doorbell buffer, and we found out a bug on it. And how we did it? Like, we smashed those drives really hard. Like, all those reads that we could do and writes that we could do, we just smashed them. After some time, there was an error that encountered, and they found out that this was the problem. So there was a patch released later on. This was fixed, but still it was causing some delays in our migration. And oh boy, the networking really rocks on GCP. So if you compare it to anything, I have never seen a better network stack than you can see there. So some numbers now. How we've been comparing that? So as you can see, there is a Cassandra replication factor 4, there is Cassandra replication factor 3, there are some numbers, etc. The point is that really the running cost of Scylla is really lower than running cost of Cassandra. So this is a bottom line. If you are on the money side, just sign that and go there. So what we decided, like, we knew where we are heading, but we didn't have yet the solution. But we already talked to Scylla guys, and we signed the support and the contract with them because we wanted, like, we know where we're heading. We wanted to get Scylla as fast as possible. So ScyllaDB migration. And now it become funny. So this is what we ended up with. So we have a GCP API endpoints, then we have OVH, ScyllaDB deployment. Each of that bubble is one different city. So we have really like cross-city and cross-country deployment of ScyllaDB cluster. And this is what we actually will have in production. So the plan. The plan was order hardware in 3 locations, set up a dedicated networking between those 3 locations, between GCP and OVH, start feeding data, release new version of application that can work with Scylla instead of Cassandra, switch traffic. How hard can it be, right? Well, click. It went downhill from there. So we ordered the servers, and it's like after 3 weeks, they told us that there is a shortage on NVMe drives on the market. So they are not like, you can't buy any NVMe drives. So we were like, why? What's happening, right? So this was like one of the biggest problems that we had. The second one we thought like, yeah, getting a dedicated line between GCP and OVH, direct connect, it seems like not a big problem. You can just use the console in GCP and click it and buy it, and yeah, you have it, right? But on the other side, it was like terrible nightmare, several weeks down the road, and we have a solution right now. But it really delayed the project. NVMe drives arrived, right? And that happened like 2 weeks ago. And we ordered it in September. So we needed to execute fast, and Glauber just said, okay, we have a plan for that, right? The migration and everything, like, okay, you're getting the hardwares and everything, and like, sort of, well, let's execute how it comes, right? What can be done first, then let's do it, because I'm not gonna draw any Gantt chart for anybody, create a GitLab ticket issues or something like that. Like, no, we're not planning it, let's just do it. So we did it, right? So last week we had 14 machines in 2 locations, and we started like throwing data there, right? So as Adam mentioned, like we are throwing 0.1% of data. Actually, that was an error that we figured out later, and it was 100% of the traffic. But Glauber was happy, Door 2, so. And we were happy too, because like we have been playing it on the safe side, so and like double safe side, because we have been doing a security meetup at that point. So we basically went to safe location, the safest location that you can imagine. It was an atomic shelter. We have having fun, drinking beer, and really enjoying that, looking at the charts, and everything was working perfectly, right? And we hit Scylla with the shadow of live traffic. As I said, it was 100% of it. So I was like poking here and there, and I had been thinking about like, let's do it like on the stage, let's switch the traffic to live to Scylla, and I said, no, please no. So this was the discussion. Yeah, we have the servers, let's do it, right? Do we have the third replica? Well, no, we didn't, right? So this was like, let's see what can be done, right? Actually, guys, today morning at 8 o'clock, local time, we received the remaining servers, and Adam was working during the presentation and the opening keynote, and he managed to put the remaining servers to the ScyllaDB cluster, and is hitting right now the ScyllaDB cluster with shadow traffic from our live system. It's not reads, it's only writes. And this is it. So the point here really is, from our company, that what you can learn is like never stop innovating. We have been changing the database and the system around it so many times, and whenever we hit a roadblock or any big problem, we just like rethink it, and we have to redo it. Then let's redo it. We don't care that some things takes longer. Yeah, we started the POC in March. But really, never stop innovating and never stop changing. So if you are considering going for Scylla from Cassandra, I don't know why you didn't do that last week. That's it. Thank you very much.